Firstly, just I'd like to thank everyone for coming along tonight. It's not very often we get a big crowd like this in front of engineers to explain what we've been doing for the last few years, but really appreciate everyone's time to come along and listen to us. We've already had the introductions, but I'm joined by Brian and Rob, so we'll both do a bit of handing over just to cover the technical aspects of the project. So I might just start with our role. So a lot of people ask who are AECOM. So we've operated an office here in Rockhampton for about 17 years. We have 30 local staff, but we're a much bigger beast than that, I guess, if you're looking at a global perspective. So you can see the graphic there. We're in a lot of countries, we have a lot of staff, and we do this kind of work fairly regularly with flood mitigation projects. So that's just a few examples. This is some work that we have been doing, international sort of projects, but also some projects locally as well. One on the left is actually a major flood pumping station and flood gate. Got a big gate up in the top there as well, swing gate, and then we've got some earth levees there as well. So it just gives a snapshot. So in terms of our role, so we were engaged by council, and ultimately we were there to assess the technical feasibility of the South Rocky Flood Levee project. Our role is to provide independent advice and technical analysis. We're not here to say whether the levee should proceed or not. We're here to give all the information for ultimately you to make that decision. There's a lot of guidelines and technical standards that surround levees. Levees are a major sort of infrastructure projects, and so we have to align to those as engineers. We also have obtained inputs from a range of stakeholders throughout the design process, and overall there's 3 of us here, but we're going to be talking for about 100 technical specialists from AECOM who have been involved on this project, both in Australia and the US. So I'll just quickly step through a few key definitions, because we will talk about this throughout tonight and probably in the Q&A as well. Levee, I've got a little definition there, but I will have a slide shortly just to explain that. Most people, I'm pretty sure, are aware of what a levee is. We will talk about average annual damage, and so that's the cost, the long-term annual cost to the community and the economy due to flood damage. And so when we do economic evaluations of levees, that's something that we look at. We look at what was the damage before annually and what is it afterwards, so that we can see how that levee performs. Afflux is another key term that's used fairly regularly. Some will be aware of that, but afflux is basically where we put an obstruction in a flow path. We have an increase in water level upstream of that obstruction, normally a decrease in flood levels downstream. So when we're talking about afflux, that's what we're referring to. Benefit cost ratio is another one which will also be discussed tonight. So basically that's a ratio between economic benefits of a project and costs. So when the BCR is above 1, that's normally an indication that it's worth considering for funding and for implementation. Lastly, and probably the key one which I'll cover, is annual exceedance probability. Now, when we come to do risk assessments and flood studies and studies of major river systems, and as engineers we always talk about annual exceedance probability. So that's the chance that you would have a flood at equal to or greater than that in a given year. So some people would have heard the Q100 or the 100-year ARI flood. That's used fairly regularly. We won't be saying that tonight. It's a terminology that can be misunderstood by the community, and some people think if you've had a 1 in a 100-year flood, you won't have that for another 100 years. That's just not the case. Statistically, what we'd prefer to say is you've got a 1% chance of that happening each year. Emerald's a good example. So Emerald had a major flood in 2008, which was a 1 in 70-year flood, and then they followed that in 2 years later and had a 1 in 130-year flood. So they've had 2 major floods within 2 years of each other. Statistically, that's just how it goes. So in terms of levees as a flood mitigation option, as Peter mentioned, there's a range of different options, and levees aren't always the answer. Levees are used in particular circumstances where it warrants them. But if a levee is a potential option, then what we're normally looking at is raised predominantly earth embankments. However, there are other types of levees which I'll go through as well. Just in terms of how they get used around the world, so there's about 48,000 kilometres in the US that the US Army Corps knows about. They expect that there's another 150,000 kilometres that they don't have documented, and that's across almost 12,000 different systems. So the statistics are pretty mind-boggling. You've got 2/3 of the US population is behind the levee over there, so it's frequently used. There's several 100,000 kilometres then when you sum that up with the US and Europe, and even in Australia we've got several thousand kilometres used in Australia. So they are used around the place. So just some examples. I thought it's worthwhile just doing a quick snapshot. These aren't all the levees, but these are some key ones. This is in Rocky. This is in our backyard. So this is the Dowling Street Levee, Kershaw Gardens, for those familiar with that area. So it's an 800 metre long crib wall system. So that particular levee was put in place in 2016, protects about 20 homes. You can see on the left, that was before construction, on the right, after construction. And this was it during the flood that we've just had. So it's a bit hard to see, but that's the levee running around here. I'm sure everyone knows about this, all those locals familiar with the area. So this is our North Rocky Flood Mitigation Scheme, stage 1 of the scheme. Now, there's a bit of background to this project in terms of planning, but the works for this project isn't just the barrier. That's what people saw, but prior to this there was a significant amount of backflow prevention works done on the stormwater outletting to Lakes Creek Road, and also a significant amount of works to the sewer system to prevent ingress of floodwater back through the sewer. What went hand in hand with this is then a temporary flood barrier, which was about 380 metres long. That was rolled out on Ellis and Rodborough Street. And we had a number of temporary pump stations set up as well at key points to collect any minor seepage that occurred and pump that back over. So I know a lot of people would have seen those out and about with the trucks pumping some of those flows back over. So that's, you can see the system set up, and then bottom left during the flood. Probably the better ones are actually these. So these are the actual aerial imageries showing what actually occurred during the peak of the flood we've had this year. So probably this one here. So for those not aware, the Lakes Creek Road is actually a high point all the way along, and we do that system in itself performed as a levee. So the road and rail there are higher than the flood height, all the way up to a 1% annual exceedance probability. So it's quite a high level of flood protection offered by Lakes Creek Road. The issue we've had previously is that the river's gone through the stormwater pipes, backed up into the area in behind Lakes Creek Road and flooded those properties. And it's also come back up around the creek and inundated back through that way as well. This is a backwater area of the floodplain, and with those backflow prevention devices on the road, and with the barrier, which you can see in a few of the shots there, we can actually, particularly this one, that's where the river came up around the creek, and we cut it off by the barrier and protected the homes in here. So there's about 400 properties protected with this stage 1 of the scheme. And stage 2 of the scheme is to ultimately move that barrier further down and protect more properties and move it down to Water Street. But Water Street requires reconstruction in order to achieve that. So that's a future stage of the scheme. And all the neighbours up in Mackay. So Mackay's had a flood levee system since the 1970s on the Pioneer River. It's a mixed type system, so they have earth levees, they have vertical flood walls, they have crib walls, very, very similar actually to the South Rocky flood levee proposed here. Longer than ours, 13 kilometres, and across 7 different levee systems you can see on both sides of the Pioneer River. So that system's been in since the 1970s. It's protected Mackay on numerous occasions, 2008, 2010, and even in some of the recent flooding we've had this year. Charleville, most people are probably aware of this one as well. So completed in 2009, upgraded slightly in 2013. It's protected against 3 flood events since construction. Again, it's a combination, so you've got some earth levee components, we've got gate crossings across the road like we'll have here, and some temporary barrier as well, and some vertical walls. So that's another example of a flood levee system used in rural Queensland, $20 million cost. And after that one, Suncorp have done some assessments, so average insurance premiums, $990 a year down to $400 after the levee was completed. And it's actually paid for itself already after, what's that, about 8 years. So you can go to the Hunter Valley. The Hunter Valley scheme is enormous. So it's got 160 kilometres of flood levee in the Hunter. There's 5 basins, 3 spillway overflow points, and basically it was the flooding that occurred in 1955 which really spurred the council, the state government, the feds to implement this scheme. But it's mind-boggling, 160 kilometres of levee, and it's protected a number of the townships there in 1971, 1977, 2007. So it's been there for a long time. Launceston, so down in Tasmania. Again, this is another good example of a scheme that was completed earlier, quite some time ago, and was starting to become structurally deficient due to old standards and codes and ongoing issues with not maintaining some components. So they've got in there and they've actually reconstructed the scheme. So it's a 12-kilometre levee system completed in 2015, so only recently. And that's a $60 million project which protected in the 2016 event, which was quite a significant flood event down there. I'll get in front of everyone who's going to ask the question about Lismore. So we'll put the record straight with Lismore because the media did a pretty poor job, to be honest, around explaining what happened in Lismore. The Lismore flood levee system was completed in 2005. So it's protected the CBD of Lismore in 2005, 2007, 2009. The cost of those 3 events alone has already paid for itself plus almost again with the levee system. So it's a 3 kilometre long levee system, and it was $20 million. And as all you probably know, it overtopped in 2017. So that particular levee system was designed for a 10% annual exceedance probability. So 10% every year you'd have a chance you'd get a flood greater than the levee system. So it was a fairly low level of immunity offered by the levee. It was what was affordable at the time. And I've just included up here at the top right, that's actually the original design and showing that there were 2 spillway points to allow flow into town when there was an event larger than the levee was designed for. And the photo on the bottom right is exactly what occurred. And you can even see on their gauge, they talk about with the community when it reaches a certain gauge height, when levee overtopping will start to commence. The levee did not fail, it did not breach, it did not give way, it simply overtopped, which it was designed to do in events larger than what it was designed for. In terms of design criteria and standards, there's a number of relevant design guidelines and standards. The one on the far left is really good news for the engineering industry. The Queensland State Government is now regulating levee banks and has been for a couple of years now. It was something that was much needed to make sure that levees are designed to the right codes and requirements. So there's now a requirement for a council, as in this case, to actually make application under the new levee regulations, and there's specific guidelines and requirements that levees have to meet in order to achieve approval under those regulations. The Queensland Levee Guidelines make significant reference to the International Levee Handbook. That's been the work over 5 or 6 years from the international levee community across multiple governments to basically pull together the international best practice when it comes to levees and put that in one big guideline. And that's the particular guideline that's been adopted for the South Rocky Flood Levee planning and design. So probably just moving through the alignment, because that's probably the very first place to start. First question that we always ask is, well, what are we trying to protect with this levee system? So just to help everyone, North Arrow is just here, so north this way. And so the first question is, we've got obviously Lower Dawson Road. Everyone's aware that Yeppoon North and South have now been upgraded to provide immunity of the Bruce Highway into town, but then diverting to Upper Dawson Road. So Lower Dawson Road is a particular focus to try and protect that. There's also a number of businesses shown in orange, park, schools and infrastructure in blue, and then residential areas. So this was the original alignment put forward in 1992, which Peter showed a bit of a map out of the study back then. And that's where we started with the study. First, as we worked through this, there's a number of things that probably pop up for most people. It did encompass the key infrastructure and the residential area and commercial buildings. this is a key flow path, and I'll go through this in a bit more, but this is the roundabout, and this is going out through the Yeppen crossing and coming into town. The flow through this throat here, through Yeppen North as we call it, is significant, and it's a very important flow path for the western floodplain. The implications of the levee here causes the majority of the effects back upstream through the western floodplain and back to the airport. And so the alignment here, the choice of the alignment needs to be made very, very carefully. So that was a key issue with the old 92 alignment, is it jutted out a bit, and that wasn't going to be good from a hydraulics perspective. At the time, probably unknown back then, but now we do know that it crossed right through the middle of a wetland here, and not just any wetland, that's one of national significance. It's a key wetland for the region, and it also has significant cultural heritage value to the Durrumbal people. And so that was a key issue with the original 1992 alignment crossing through there. And we also had some interference with some fairly major overhead transmission lines coming into Rockhampton at Powerlink Own. So the study commenced with us looking at alignment options, and so we generated a number of options which you can see there, different pros and cons, as always, with this kind of infrastructure, some people being left out, some people being left in, and obviously different costs as well associated with those different levee alignments. The process then becomes a fairly rigorous one over about 5 or 6 months. So what we looked at is, on a number of different disciplines across our technical teams, what are the pros and cons of each of those alignments? And then we basically run through a process of scoring and workshopping. So we had a number of workshops with key stakeholders. So we're talking state government inputs through a number of those, and basically trying to arrive at what was the best balance with the selected levee alignment. It's always a balancing act with any of this kind of infrastructure. What that left us was the selected alignment, which you can see there. So you'll notice that we changed the alignment fairly significantly around the Hastings site. We've pulled it in, tucked it in quite significantly, and also incorporated some fairly important bends in the levee there to take the flow and divert it smoothly around that end of the levee. We've moved well away from that wetland and onto the Fitters Street area. And similarly, we've pushed right over to Rosehill Park and got around the back of the treatment plant before coming down the main strip down Quay Street. So one of the key questions we get asked is, what does it look like? So I've tried to use some photos here just to give an indication of what the system looks like in the different areas, but we will show some maps later on which shows that in a bit more detail. So this particular location, that's Walter Reed. Most people are familiar with that landmark. So around the Walter Reed Centre, particularly when we're getting closer up Quay Street past Derby Street, we're looking at a full demountable stop log system, which is the bottom system you can see there. Reason being is we don't want any levee shown along the riverbank there. It's a key location for the community, and the visual impacts of a levee along there would be fairly horrendous. So that particular system involves a footing that would be permanently there, and then before flood events, the stop log system would be erected when the first warning of flooding came. Further down, we also past Walter Reed, we start to use a composite wall system. So there's an example of that there, where we have a small permanent wall levee, which can then be have the panel system incorporated on top, just to give that extra height that we require along that section of the riverbank. So as we move further down the river, particularly out past the boat ramp and further down, we start to convert to a crib wall system. So crib wall system is the same system used at Dowling Street at Kershaw Gardens. So again, it's somewhere you could go and have a look at what it looks like, but that's the image there, the top right, out at Kershaw Gardens. And that's the system that will be used due to space constraints. It starts getting tight around that particular area down past the boat ramp, so we're using that from a space perspective. When we do get then into the rural areas where we've got more space, we adopt the earth levee. And so it's fairly sort of stock standard. We'll talk a bit more detail around the specifics and the material properties and what's required, but we go an earth levee with, and in this case we're adopting a vinyl sheet pile on the top. The intent of the vinyl sheet pile is purely just to provide the freeboard. And again, I'll touch on freeboard and what that means shortly. But for the most part, it's the earth embankment, grassed, and in some locations rock protected where we need to from velocities. We do have a number of gates where we're crossing existing roads, and we also cross the North Coast rail line and require a gate structure there as well. Gates across roads and rails are done all the time in levee systems. They're nothing new. In this particular case, you can see a number of examples there. Both Australia, Europe, US, they're done fairly frequently. So ultimately, it's about bringing the levee and terminating on either side of the road or rail, and again, putting demountable barrier in before the flood event arrives to actually close that opening up. But in normal situations, the levee will terminate either side of the road and rail and continue onwards. Pump stations. So we do have a few pump stations, obviously. We'll talk again about those in a bit more detail. Top one's there, just showing an exterior and interior of a pump station we've designed recently. That's a much bigger pump station, just to put that in perspective. So we're talking there a 30 cubic metre a second pump station, so 30,000 litres a second. So again, we'll put that in context as we go through, but that is a much bigger pump station. Obvious intent of the pump station is to collect stormwater. If we do have a river flood occurring at the same time, so collecting that stormwater from the local runoff and rainfall and pumping that over the levee. It's a frequently used bit of infrastructure for most levees. We also have a number of backflow prevention devices. That's just an example I've shown there, but there's a number of different types, different manufacturers and different uses and different conditions. But basically we put those backflow prevention devices on existing stormwater outfalls, again to prevent the river from backing up through our stormwater network and flooding the interior side of the levee. Very similar to what's been put out there for the North Rocky scheme. So again, if you took a walk down Lakes Creek Road, you'd see a number of these that have been installed as part of that scheme. So that's just a quick snapshot. It doesn't show all the technical jargon, it's just something fairly simple to see how the levee's laid out in terms of configuration. So again, you can see north up this way. So if we just work our way, so we connect in up at the new Jellicoe Street intersection on Lower Dawson Road as part of the Yeppan North project. They've raised that area there, so there's a connection of the levee there. Floodgate over the North Coast rail line, and then we work our way down. Again, this is the key flow path through here, and also obviously down the main river. So we're tied along this area here, incorporate a couple of gates in this area as well to facilitate normal road access. There's a pump station located in proximity to the Hastings site where we're collecting stormwater from this portion of the catchment. We then turn out around Fitters Street, so this is currently Fitters Street along here. We have an emergency spillway, again we'll talk what that all means in this location here, and a pump station. That's actually our biggest pump station of the three in the Fitters Street area. We're then out through Roselle Park, protecting most of the sewage treatment plant around the corner here. Again, we have a number of floodgates. We have then a pump station on the main drain. Again, we'll go through that. Most be familiar with the main drain system, but we're pumping from there. And you can see we do transition to a crib wall system. So we're going that retaining wall system due to space around the corner here. And then we do transition back to earth. And then ultimately, we do go to our composite levee through that Wolf Street area where we get tight for space, back to earth, and then ultimately then the fully demountable system through the main CBD area to ensure that there's no visual impacts. So in terms of just a summary of the configuration, we'll put again a bit of the technical behind this, but that just gives a quick snapshot of the different elements. We'll talk shortly about design immunity of the levee and what that means, and freeboard, but at this stage it's a 1% annual exceedance probability design criteria for the levee system, which is equivalent to 9.6 on the gauge for those familiar with gauge datum. That incorporates then a 0.9 metre freeboard, which is quite significant, probably one of the largest that any Queensland levee has got on it at the moment, and we'll explain why. Working through, we then have a number of levee types, so you can see the breakdown of the levee types that we just discussed before. Ultimately, earth levee is used predominantly, 5.6 kilometres. It's the cheapest, it's the most effective, and we use that wherever we can. We do have transitions in between levee types, and that's really important. It's a key consideration from a technical perspective about how you transition from one levee type to the other. In history and time gone by, they can be weak points, and so there's a lot of guidance around design of those transitions. In terms of interior drainage management, again, we'll talk a bit more about this, but we have 2 detention basins, one at Fitters Street, one at Hastings, 3 pump stations. So again, trying to put that in perspective, you can see the discharges, duty discharges there. So, think of a 1 litre milk container. We're talking 9,000 of those a second at Fitters Street. We're talking 1,000 at Hastings and then 3,000 litres a second at the main drain. Culverts, we obviously have culverts to allow flow. So where the river isn't up and we just have a local storm event, we want that runoff to get through the levee system. And so we have a number of culverts, 13, that allow the flow through the levee in normal operation. And each of those have backflow prevention to prevent the river from backing up through those culverts. We do have some complementary works or associated works for Lucia Street and Wharf Street, both stormwater drainage upgrades to actually facilitate interior drainage behind the levee and get that water to the main drain to then be pumped out. There's obviously a number of existing services, which I won't go through all those in detail now, but there's a number of protection and treatment requirements for those services like power, gas, electrical. And then we have our emergency spillway. So it's a 400 metre long spillway at Fitters Street. Again, we'll talk in a bit more detail about that.